Hello everyone, my name is Matheus de Camargo Marques, and I brought an implementation of a MinHeap. I want to show a few things that are properties of Elixir and Erlang, things that I like to use. In this case, I'm using only Benchy version 1.31 and Elixir version 1.16. Here I have a benchmark file where I perform 50,000 insertions, extract the minimum value, and I already have the result from this benchmark executed and prepared. It shows that if you analyze it, you will discover that using GB tree is a better implementation. I have already configured it here to use the GB tree implementation. In this case, I created a MinHeap. What is the logic of a MinHeap? The behavior is that it is a binary tree, so it divides into two values, left and right. I think this is the analogy people use. But what's the deal with MinHeap? It always brings the minimum value, right? So we have the creation of callbacks, which are function signatures. Anyone who wants to have a MinHeap behavior will need to insert these functions implemented, such as creating a MinHeap, inserting a value into the MinHeap, and extracting the minimum value from the MinHeap. Here, the values returned are quite generic, but we could make them less generic. This MinHeap is, in fact, a facade, a design pattern. I've seen it used with other design patterns like ports and adapters. Essentially, it's a facade, so I define the new, but behind the scenes I'm calling something to execute things. The module that is executed behind the scenes comes from the configuration I created. I configured the MinHeap and its implementation as the GB tree module. If it's not configured, it will throw an error, but if it's configured, it will use the implementation module. 258. Why did I use this type of approach? I wanted to show how we can test the performance of applications and how Elixir's system works. As I mentioned earlier, it's a live system. I wanted to show this common design pattern and some structures we can see here that come from Erlang's standard library. This was even done by Professor Ernie Anderson, called General Balances, and you can use trees through this Erlang module, like lists and maps. Let me explain why this type of approach is used. If you search for circuit breakers, you will understand a bit better how to take advantage of this. But at this point, let's say you operate a system in telecommunications and something goes wrong with the network. You need to switch providers or change the service you are currently using. In payment processing, for example, there are multiple infrastructures for processing payments. 703. When there's an issue, like a payment is too slow, we signal it with a flag and we get an alert. As an operator, I notice it's becoming slow, maybe a